Okay, let's look at the homework 5, problem number 7, right? So it says that the time rate of change of a rabbit population P is proportional to the square root of P, right? So let's write that in a different equation. So rate of change of population, so dP over dt, right? So this is proportional to square root of P. All right. So, and then we have some initial conditions. So when t equals 0, initial population is 100. So we know that, so P of 0 is 100. And also, it says that, let's see, it's increasing at the rate of, so P prime of 0, which is dP over dt, is equal to 20 rabbits per month. All right, so we have that. All right, let's solve that. All right, first, we can actually find out what the K is. So let's find that out. So K is going to be, so if you plug in P equals 0, so let's do it here. So P prime of 0 is equal to, all right, so it's going to be K times square root of, P of 0 is 100, so that's 10, so it's a 10K. And this is supposed to be equal to 20, right? So this means that the K is, so divide through by 10. So K is 2, right? So we have this equation, dP over dt is equal to 2 times square root of P, right? So this is a separable equation. So we can just divide it through by 2 square root of P, right? 1 over 2 square root of P dP over dt is equal to 1, right? Then we can take the antiderivative with respect to t. So dt, right, antiderivative with respect to t, right? Then you see that t and t cancel out, right? Then you get, let's see, I don't like the way this is written, so this is going to be the same thing as, right, 1/2 p to the, right, p is on the bottom, so it's negative power, square root, so it's a 1/2 power, right? So let's take the antiderivative. So antiderivative of p, let's see, 1/2, so I put 1/2 in front, right, p, right, power rule, add 1 to the power, so it's going to be 1/2 power, divided by 1/2 is same as multiply by 2, right? Then this is equal to, right, t, antiderivative 1 is t, and then you have some constant c1, all right? Then we can, luckily, we can cancel 2 and 2, nice and clean, right? Then we want the population P, so we can just square both sides to get the P isolated, which is going to be quantity T plus C1 squared. All right, so we can find the C1 by using the initial condition. Since we already used the, this P prime of 0 equals 20, and this is that, and we can still use this guy again, all right? So we have P of 0 is equal to, all right, so you have a C1 squared, which is equal to 100, right? Which means that take the square root of both sides, C1 is going to be square root of 100, right? Plus or minus, so it's going to be plus or minus 10, right? So you can have, let's see, so you're going to have a p of t is equal to, right? So actually, square root of p is never negative, so it doesn't make sense to have c1 negative, so it's going to be actually just a positive one, all right? So this is going to be, let's see, quantity t plus 10 squared, all right? All right, let's see. So we want to see how many rabbits will there be after 1 year later. So this is t is in month, so we have to put the p, find p of 12. All right, so this is going to be 12 plus 10 squared, which is 22 squared, and which is going to be equal to, what's that? 22 times 22 would be 484, right? So it's a 484, right? So this is the number of rabbits after 1 year. All right, that's it. I hope that this was clear.